Tonight, the night sky puts on a show. The moon has a date with Jupiter, and 6 planets are lined up for your viewing pleasure. This is Astronomy Daily.
I'm Avery.
And I'm Anna. Season 5, Episode 49, Thursday, the 26th of February, 2026. Lots to get through today, so let's go.
If you've been watching the western sky after sunset this week, you may have noticed something spectacular building. 6 of the solar system's planets are above the horizon simultaneously right now. And tonight is the visual highlight.
We've also got a deep dive into some extraordinary new findings about our galaxy's magnetic field. A quick update on Artemis 2, the identity of the astronaut at the center of last month's historic ISS medical story, and a brief heads up on a scrubbed military hypersonic launch that we'd been previewing earlier in the week.
Big show. Let's get into it.
So, Avery, I know you've been watching this planet parade build all week, and tonight is the moment we've been waiting for.
It really is. As darkness falls this evening, if you head outside and look west, you'll see the moon sitting right next to Jupiter. It's a stunning pairing, and it's the centerpiece of a 6-planet alignment that's been building throughout February.
Let's break this down. 6 planets above the horizon at once: Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune. How does that work exactly?
The planets orbit the sun in roughly the same flat plane, the ecliptic. So from Earth, they always appear in a band across the sky. When they spread out enough that several are visible simultaneously, we get what astronomers call a planet parade or alignment. Right now, they're nicely spaced across that band.
Now, I want to be honest with listeners here because not all 6 planets are easy to spot. Some are quite the challenge.
Absolutely right. Jupiter is by far the star of the show tonight, pun intended. It's high in the western sky after sunset, unmistakably bright, and sitting just below the waxing gibbous moon. If you only look once this week, look tonight. Look for the moon, and that blazing point of light right beside it is Jupiter.
What about the others?
Saturn and Mercury are visible, but low on the western horizon, and I mean low. They set not long after the sun, so you've got a fairly tight window. Venus is actually dimmer than you'd expect right now because it's also sitting low in the twilight glare. Uranus needs binoculars, and Neptune really requires a telescope, and you'll need to wait until the sun is fully below the horizon before even attempting that one.
So Jupiter and the moon for casual observers, extra kit for the dedicated stargazer.
Exactly, and here's something to keep in your diary. We're 1 week away from the full moon on March 3rd, and this isn't just any full moon. It's a total lunar eclipse, which means we're heading into a blood moon. We'll have full coverage of that next week.
Something to really look forward to. So tonight, get outside, find the moon, and say hello to Jupiter right beside it. Beautiful.
Now to the heart of our galaxy. Astronomers using the world's largest radio telescope array have peered deeper into the Milky Way's central molecular zone than ever before. And what they found is extraordinary.
The region around Sagittarius A star, our galaxy's supermassive black hole at the very center, is a violent, turbulent environment, and new observations have revealed hidden chemistry swirling through that chaos.
What the researchers have done is essentially map the complex molecules in the cloud of gas and dust that surrounds Sagittarius A star at a level of detail that wasn't previously possible. They're finding chemical signatures that challenge how we've thought about that region of the galaxy.
When the lead researchers describe this as just the beginning, that's telling, isn't it? That phrase usually means they've opened a door rather than closed one.
Precisely. This is a proof of concept for a new era of galactic center observations. As the array's capabilities continue to improve, the resolution and sensitivity will only get better. We're talking about unlocking processes at the very engine room of our galaxy. How molecules form in extreme environments, how the black hole's radiation and gravity shape the surrounding chemistry.
And it all feeds into the bigger question of how galaxies like ours evolve over cosmic time.
Exactly right. It's one of those stories where the science is genuinely exciting right now, but the best discoveries are still ahead of us.
As we've been reporting throughout the week, NASA's Artemis II Space Launch System rocket has now been rolled back from Launch Pad 39B to the Vehicle Assembly Building.
The crawler transporter made the journey on Tuesday, a spectacular but somewhat sobering sight, that 6.6 million pound vehicle hauling a rocket that was supposed to be heading for the moon.
The issue is with the upper stage, and engineers now need to diagnose and repair whatever's causing the problem in the controlled environment of the VAB, rather than on the pad. The current expectation is that the earliest realistic launch opportunity is now early April.
Interestingly, President Trump gave a State of the Union address on Monday and gave a shout out to the Space Force, calling it, and I quote, "my baby," but notably didn't mention the Artemis II crew by name.
Make of that what you will. We'll continue to follow this as it develops, but for now, no moonshot in March.
Now, to a story that first broke last month and which has just had a significant new development. NASA has now identified the astronaut at the center of the first ever medical evacuation from the International Space Station.
To recap for anyone who missed the original story, in January, SpaceX's Crew 11 mission returned to Earth early. One member of that crew had experienced a medical issue serious enough to warrant cutting the mission short and bringing the entire crew home.
That was unprecedented. In the entire history of the ISS, we'd never had a medical evacuation at that level before.
NASA has now shed more light on what happened, specifically at the request of the astronaut involved, who wanted their identity made public. The crew of Crew 11 included NASA astronauts Mike Fink and Zena Cardman, JAXA astronaut Kamiya Yui, and Roscosmos cosmonaut Oleg Platonov. It turns out it was Mike Fink who needed the medical help. It was explained that he needed some more imaging scans performed, which just couldn't be done with the equipment on board the ISS. So, home they came. However, the nature of his ailment still hasn't been revealed.
The details emerging give the medical community and space agencies important data for future long-duration mission planning. It raises real questions about how we handle health crises in orbit, what protocols are in place, and how they might need to evolve, especially as missions eventually go beyond low Earth orbit.
A deeply human story alongside all the engineering and science. We'll link to the full NASA disclosure in the show notes.
Right, and now for what might be my favorite story of the episode. And honestly, it's one of those pieces of research that just makes you stop and think about how strange and wonderful our galaxy is.
Tell me everything.
So, a team led by Dr. Joanne Brown at the University of Calgary has produced the most detailed map yet of the Milky Way's magnetic field. And what they found has fundamentally surprised them.
Let's back up a second. How do you even map a magnetic field across a galaxy?
Great question. The technique is called Faraday rotation. When radio waves travel through space, they interact with electrons and magnetic fields, and that interaction causes them to shift slightly. They rotate. Dr. Brown's student Rebecca Booth described it brilliantly. Think of a straw in a glass of water looking bent because of refraction. Faraday rotation is the same concept, but it's electrons and magnetic fields bending radio waves instead of light through water.
That's a genuinely beautiful analogy.
Isn't it? And by carefully measuring how much those radio waves shift, the team can trace the invisible magnetic lines flowing through the galaxy. Now here's the astonishing finding. If you could look at the Milky Way from above, the overall magnetic field runs clockwise. But in the Sagittarius arm, one of our galaxy's spiral arms, it runs counterclockwise, a complete reversal.
They must have known about that reversal before, though, right?
They knew about the reversal, yes. What they didn't understand was how the transition happened, how the field switches direction. And this is where the new data delivered a genuine moment of discovery. Dr. Brown describes it perfectly. She says one day her student Anna brought in the new data, and Brown's reaction was, and I'm quoting here, "OMG, the reversal's diagonal."
I love that. An OMG moment in astrophysics.
It's wonderful. The reversal doesn't happen in a flat, clean plane as previously assumed. It runs diagonally through the galaxy in 3 dimensions. That changes everything about how we model the magnetic structure. The team has now built a new 3D model to explain it.
And why does it matter? Why does the galaxy's magnetic field matter at all?
Well, as Dr. Brown puts it, without a magnetic field, the galaxy would collapse in on itself due to gravity. The magnetic field is essentially one of the forces holding the whole structure in balance. Understanding how it's shaped and how it's evolved over billions of years tells us something profound about how galaxies like ours come to exist and persist.
Absolutely mind-expanding. We'll have the research details and links in the show notes.
And finally, a quick update on a launch we'd been previewing earlier in the week. Rocket Lab's HASTE suborbital rocket was due to lift off from Wallops Island, Virginia on Tuesday, but the mission was scrubbed due to out-of-bounds launch commit criteria.
No new launch date has been announced yet, but just to give listeners the full picture on what this mission actually is, because it's genuinely fascinating.
It really is. The mission is called That's Not a Knife, and yes, that is a deliberate Crocodile Dundee reference. And it's carrying a scramjet-powered hypersonic demonstrator called DART-AE, built by the Australian company Hypersonics.
A scramjet being the key technology here.
Exactly. A scramjet, supersonic combustion ramjet, ingests air flowing through it faster than the speed of sound and burns fuel in that airstream. What makes Hypersonics' version particularly interesting is that it runs on hydrogen rather than kerosene, making it essentially zero carbon dioxide emissions at hypersonic speeds. The DART-AE is designed to validate advanced propulsion, materials, and guidance systems for the U.S. Defense Innovation Unit.
And HASTE itself is Rocket Lab's workhorse Electron rocket adapted for suborbital hypersonic testing.
Correct. This would have been the 7th HASTE flight. The mission will fly, just not this week. We'll update you when a new date is confirmed.
That's everything for Series 5, Episode 49. An enormous thank you for joining us today.
Lots to look at, both in the sky and in the science. Don't forget Moon and Jupiter tonight. Get outside if you can.
If you enjoyed today's episode, please do subscribe, leave us a review, and share us with a friend who loves space. We are Astronomy Daily, part of the Bytes.com podcast network. Find us on all major podcast platforms at Astronomy Daily and on social media at Astro Daily Pod.
We'll be back tomorrow with more from the universe. Until then, keep looking up.
Clear skies, everyone.
Astronomy.